Hello guys, welcome back to the channel Jai Shri Krishna. So in today's video we will be looking into divisors of a number problem. It is the last problem from Striver's basic math folder. So here we are given an integer n and we need to return all the divisors of that number n. So if we look into the coding implementation part, if we look into the brute force approach, then we will be iterating the loop from 1 to n and we'll simply check if that number is divisible by I or not. And we will, if a number is divisible, we'll simply push it in the vector. And this is fine for smaller numbers, but it is not great for larger numbers. So the time complexity will be big of n. So we can try running the code and we can try submitting as well. So after submitting, if we view the advanced analysis, the time complexity is big of n as the loop iterates up to n, and space complexity is also big of n because array can store up to n elements in worst case. So this is fine, but what we have to do is we have to slightly optimize it. So we can iterate the loop till square root of n, and what we can do is here we can also add another condition as called as counterpart. So what it will do is, if I is a divisor of n, then n divided I will also be a divisor of n. So in that case we can add the elements which are greater than square root. Okay, so what we can do is, if I is not equal to n divided by I, so in that case we can do array dot pushback n divided by I. But here's the catch: this will add the numbers not in unsorted format. So we can try running that. So we can see, like, the output is 1623, but as mentioned in question it should be in sorted form. So we can simply sort this before returning. Okay, like once the loop is completed, what we can do here is we can sort our array dot begin, comma, array dot int. So now it is sorted, so we are good to go and we can submit. Now the space complexity and now the time complexity will be reduced to square root of n. If we view the advanced analysis, now it is square root of n. Okay, so like we can see big of square root of n log square root of n, since the loop iterates up to the square root of n, and inside the loop there is sort operation on vector size of square root of n. So if we ignore the lower order terms, we can simply say it is nearly about big of square root of n. And the space complexity is also big of square root of n, at most 2 into square root of n elements in the worst case, but the number of divisors cannot exceed square root of n. So in that case, like, we can slightly optimize it uh, and reduce the time complexity and space complexity to big of square root of n. So there is this similar problem on linked code, and it is like to find the three divisors. So here we are given an integer n and we need to return true if n has exactly three positive divisors. Otherwise we have to return the false. So if n equal to 2, it is false because n has only two divisors, that is 1 and 2. For 4 it is true because 1, 2 and 4 are exactly the three divisors for 4. So what we can do is, again we can simply check for the number from I1 to n, and we can do count plus plus, and then at last we can return count. If count is exactly equal to 3, then it should return true, else it should return false. Okay. So yeah, we can see like the code is executed and accepted. So yeah, that's it for this video. See you in the next one. Until then, keep coding, keep exploring, keep smiling. Toodles.